Okay, so we already talked about the equation 3.3. If you remember, equation 3.3 was a simple step polymerization, and we use that to either measure the number of repeating units or the mirrors, or we use conversion, percent conversion of one basically or two monomers to the product, which is the polymer. So these two are related to each other. Now what if we don't have the balance between the two monomers? Then we use equation 3.7. Now 3.7 is a little bit different, but again, this is a science course, so we have to know and use and how to use basically a formula. Use different numbers. So the equation that we're going to use when there is an imbalance between two monomers is 3.7. 3.7. So dp hat or x and hat is going a little bit different. So it would be equal to 1 plus r at the bottom minus 2rp. Now what is r? So r is the ratio, the mole ratio of the two reactants. And p, like before, so p before is the conversion, percent conversion. Again, as I said, we need to practice. Go back to the folder Matthias point. Look at the practice 1. Look at practice 2. So we're going to know how to use these two, 3.3 and 3.7. Very important equations. We need to know how to use them. Not memorizing the equations. Again, how to use them. So let's look at the 3.7. So again, we remember that the R is the ratio of the number of moles of A to B. Let's say we're using A and B. So that's really the R. So the R is very simple. The mole of the A over number of moles of B. Now we also remember this polymer is made of two monomers, right? So when we looking at the number of moles of A and number of moles of B, initially we have to divide it by 2 because not both of them get involved with making the polymer. So N0 at the beginning, we have to use the number of moles of A and B divided by 2. We know what the R is, right? R was the Na over Nb. So Na would be R Nb. Now, if you take this number and put it here, so N0 would be R Nb, again for Na, plus Nb divided by 2. So it would be, if I take Nb as a factor, so it would be 1 plus R. And we call this 3.5. We're going to use it in a second. Now, we have to define what is unreacted A. So the unreacted A is original Na times, this is the conversion factor times Na. So that's the percentage was converted. Again, this we can substitute as R, right? So we can say R and convert this to Nb. So it would be R Nb 1 minus P from the equation above. For unreacted group B, so Nb would be P minus P Na. So they are related to each other. So now Nb would be 1 minus Rp. And we're going to use this in a second. So we have the unreacted A, unreacted B. So let's use those equations in the, as I repeat myself here. So we have R, Nb1 is 1 minus P, and B would be Nb 1 minus Rp. So if we put these together for the N, remember the N? So the N would be Rnb 1 minus P plus Nb times 1 minus Rp. Now we can take the Nb as a factor. So now inside the parentheses would be r minus rp plus 1 minus rp. So that becomes equation 3.6. So 3.6 is nb 1 plus r minus 2rp over 2. Now we have a bunch of them, and we're going to combine them. We had equation 3.1 at the beginning, n0 over n, initial and remaining. Now n0, we just calculated 3.5 as nb 1 plus r over 2. Equation 3.6 is nb 1 plus r minus 2rp over 2. So now dp hat or xn hat would be, we put the n0 and n, so it would be nb 1 plus r divided by 2 over nb 1 plus r minus 2rp divided by 2. Now 2 and 2 cancel, nb and b cancel. So the general equation for this step polymerization is 1 plus r over 1 plus r minus 2rp. What we call it 3.7. You don't need to know how to draw these equations, really. I don't ask you to do that. But I'm asking you to be able to use the equation in application in the problem. And that's what the science course is. So again, for this equation 3.7, there are many problems and homeworks that we did, but definitely look at the practice 2 in the folder Modules 1. And thanks for your attention.